Welcome to The Explainer. Today, we're taking a brief, honestly really fascinating journal entry from a dedicated home aquarium scientist, and we're doing a deep dive on how to optimize an underwater nursery. We're going to unpack the meticulous, almost obsessive world of hobbyist aquaculture to see exactly what makes a habitat successful. So, how do you actually build the perfect underwater nursery? Well, let's dive into that question by looking at an incredibly insightful project from a journal titled Notes on Fishkeeping. Specifically, we're looking at part 293, dated July 21st, 2026, authored by someone named Ang. Now, just pause for a second. The fact that this is part 293, that right there should immediately tell you something about the sheer level of dedication and iterative learning we're dealing with here. Ang isn't just throwing some tap water in a glass box. They are actively trying to construct the absolute perfectly optimized nursery for a very specific aquatic resident. And our VIP subject today is the Kribensis Cichlid, or if we're using the formal scientific name, pelvicachromis-pulcher, which is a variety of dwarf-cichlid. The author's whole goal in this journal entry is setting up a brand new, perfectly calibrated breeding tank just for them. You know, when you're trying to encourage fish to actually bond and breed, the environment has to be exactly right. Every single detail matters. The fish need to feel secure, comfortable, and instinctively triggered to reproduce, and getting there requires a habitat built with immense intentionality. Now, taking a look at Ang's tank setup, you'll see it relies on just 3 basic ingredients: an artificial terracotta pot cave, fine sand substrate, and a standard sponge filter. It's a remarkably simple, yet highly intentional approach. We aren't looking at some massive, complex filtration system or a heavily planted, high-tech jungle. It's totally minimalist. But as we're about to see, the magic isn't in the complexity of the items themselves, it's in the highly calculated way those items are utilized, placed, and tested. Like any good home scientist, Ang introduces the first major variable to test in this controlled environment. Let's call it the substrate swerve. Substrate, for those who might not know, is just the material covering the bottom of the tank. In a standard setup, hobbyists generally just run to the pet store and buy whatever gravel is marketed for their specific fish. But Ang is taking a slightly different experimental route here. This is exactly where a standard hobby transforms into an active experiment. Notice the stark contrast in these two approaches: aquarium store substrate versus standard construction sand. Ang opted for the fine construction sand. Why do that? Well, first off, it's way cheaper than those commercially packaged substrates you find in specialty stores. But it's not just about saving a few bucks. Using this construction sand provides a really unique chance to evaluate its actual effectiveness. Is it truly suitable as a long-term substrate specifically for dwarf cichlids? It's a live test of a much more cost-effective alternative. Okay, let's move on to our next variable. This builds into what we might playfully call aquarium feng shui, or spatial engineering. It's all about the physical placement of objects within the tank. Once you have your materials sorted out, your sand, your sponge filter, your terracotta pot, the next critical question is where exactly to put them. The author decided to consciously move the terracotta pot, which serves as the artificial breeding cave, much further to the back of the tank. And I want to be clear, this wasn't just some random aesthetic choice to make it look nice. It was driven by hard data. 6. That is the crucial number here. It took observing 6 completely separate breeding tanks for the author to notice a specific, undeniable behavioral pattern. Just think about the patience required to do that. Ang set up, monitored, and evaluated 6 distinct environments before drawing a final conclusion. This is the absolute essence of effective observation. The fish were essentially voting with their fins across multiple test environments, and Ang was paying very close attention to how they voted. And the hard data from those 6 tanks showed a pretty stark reality. The observation was that the dwarf cichlids completely bypassed the artificial terracotta caves whenever they were placed at the very front of the tank. Basically, if there were other alternatives available anywhere else in that tank, the fish would choose them over the front-placed cave every single time. It's such a fascinating insight into fish psychology. They clearly desire privacy and distance from the open glass when they are looking for a secure place to settle down. Which brilliantly illustrates this new tank layout strategy. By pushing the terracotta pot cave all the way to the back, Ang actually achieves 2 things at once. First, it completely honors the fish's natural preference for a secluded, rear-placed home. Second, and this is incredibly practical, it creates a wide open space at the front of the tank. As Ang notes, this front area is now prime real estate, completely freed up for perhaps other fish species that might be introduced into the tank later on. It's just a masterclass in spatial efficiency. But here's a really funny little nuance about their hiding habits. While cave placement is highly beneficial, it isn't absolutely critical to their survival. Ang noted that, if push comes to shove, these fish will absolutely hide right at the bottom of a sponge filter placed at the front of the tank. They'll make do with what they have. However, just because they can survive with a suboptimal front-placed filter hideout doesn't mean it's ideal. Optimizing the layout by giving them that back-placed cave simply makes the whole ecosystem more efficient and definitely more comfortable for the inhabitants. So we've talked about the results and the weight. Let's see how all this preparation actually builds into the final phase of this journal entry. We've gone over the theory, the minimalist setup, and the spatial engineering. Now, let's look at the immediate behavioral results right after implementing these specific environmental tweaks. Did the fish actually respond to the switch to construction sand and the strategic data-backed cave placement? Looking at the timeline, it reveals rapid, almost immediate success. Day 0, the setup is complete. By just day 1 or 2, some of the fish actually started to occupy the relocated artificial cave. They accepted the new real estate exactly as Ang hypothesized they would. And this rapid acceptance totally paves the way for the ultimate goal here over the coming weeks, giving the environment enough stability so that pairs of dwarf cichlids will actually start bonding and mating. I absolutely love this sign-off directly from the journal entry. Let's see how this goes in the coming weeks. Till the next post, yours truly, Ang. It just beautifully captures the true spirit of the home scientist. Because after all the meticulous planning, sourcing the sand, and engineering the layout, there comes a point where you just have to step back. You patiently wait for nature to take its course after you've set the stage. Ang fully acknowledges that the real results of this breeding tank are going to unfold over the coming weeks. To wrap up this explainer, I really want to leave you with a thought to consider. We just walked through how testing some cheap sand and simply moving a terracotta pot completely transformed a fish tank, all based on careful observation. So, how can you apply this kind of iterative observation and minor tweaking to optimize your own hobbies or environments? Whether it's your workspace, a garden, or any complex project you're tackling right now, what variables can you isolate and optimize today? Keep questioning, keep observing, and I'll catch you in the next explainer.